Yeah, thank you very much. Glad to be here and present on behalf of part of the work package 3, which is led by Magellan. This is a joint work of several people. Some of them are here in the room. Willy is sitting there, Lina and Julia are sitting over there. And I'm going to present what we have done on behalf of environmental covariates. So as mentioned, we are part of work package 3. This covariate production is not only about terrestrial data, but also about Earth observation data. This is giving quite a wealth, and it's not that easy accessible. And additionally, we of course also offer climatic data, so like projections and so forth, which come sometimes in very unusual formats. The goal is to improve the predictive power of models and to offer more options for modeling scenarios. So throwing data at problems is basically the scope. But for this, you need to have those data. They have to be accessible. They have to be well prepared. And given the nature of data sources, raw data and so forth, this is sometimes a bit challenging. So in the diagram, you see how we are connected. We are connected to work package 2. Especially in terms of disease profiles, and additionally naturally feeding into not only work package 4, the modeling activities, but also the Mood platform, which we have learned about yesterday again. So the next is about covariates needed for these different modeling activities. It's a transversal activity which touches multiple parts of the Mood project. I want to highlight the critical role of environmental factors here, which are needed in understanding and predicting disease outbreaks, including hypothetical outbreaks and disease X study efforts. We have produced in the course of the Mood project a wealth of different covariates, such as climate data, vegetation data, land use data, socioeconomic data, mobility, and so forth. So what do we gain here? Importantly, we are using high-resolution geospatial data, and high resolution is not only spatial data spatial resolution, but also temporal resolution, and we gain efficiency here. Of course, many people can do data processing, but sometimes some special knowledge is involved, especially with geographical data, or geospatial data, so to say, because they come in really sometimes very unusual formats, like point clouds in raster data and so on, which then have to be turned into something which can be more easily fed into the common analysis structures. So our scope was to turn complex data into data structure, which can then be ingested in different models and so on. Importantly, we have provided our data with license declaration, which means also data can have license, not only software, open data especially. And we have metadata accompanied by, so that you can also see how this environmental covariate has been produced. So let's say the steps how to get there. It's not only reformatting, but it's often also creation of indices and so forth. And this is then described. So our paradigm is no data without metadata. So we are notorious data hunters, scanning continuously scientific data publications, public data silos, whatever else exists. If data pop up, we check if they are relevant. Then if yes, then we process them. We go for quality check. We, of course, interact with the partners to see if they are relevant or not. And then, especially in the Mood context, it is important to also talk about proxies, because many things you cannot directly measure. You need to identify what could be a proxy to represent a phenomenon. And this, of course, involves interaction with the different partners. So an example are temperature data, which have been mentioned many times in the last, yesterday and today, which are quite relevant. But temperature data, what is it? No, it can come from different data sources. It can be from meteorological stations. It can come from satellite data, so land surface temperatures, for example, but then you may want to have individual observations, which are maps, or you want to have indicators which are aggregated. For example, you can compute naturally like averages of monthly data, but you can then also stack them and take 30 years of this particular month and then compute the statistics on top. For our pipelines, that's not a big deal, but sometimes it may be interesting to feed that into the model and see what the variable importance might be. Yeah, as I said, some tricks are involved, which means knowledge, like pixel geometry, different map projections, how to represent things, our data, especially with population data, are they counts of a particular area, are they averages, and so forth. And so this needs careful preparation. You see, we are open source focused, which is important for reproducibility of the workflows. And you see different software packages there we have been using, involving also developing partially. I don't want to go into the details here. And yeah, we talked yesterday, learned about the Mood platform, which is really important, nice to see. And of course, our efforts are feeding directly into this Mood platform, which is giving a chance to work with those data easily. So we are kindly invited, just to repeat it, to register there and explore the platform. The link is there. We'll find a convenient interface, and of course, we hope to then further collaborate on this. So where are the data elsewhere available? We are using not only the Mood platform, but also the Zenodo platform. I don't know if you know Zenodo. It's a data and software provisioning service operated by CERN. Upon publication, the Zenodo system assigns a DOI number to the dataset or the workflow or whatever you publish there. Like this, it is scientifically citable again. And interesting is also that it supports versioning. For example, we discover something to be improved in the dataset, maybe in the processing scheme, we can publish a new version on top of it. So you have still the same record there. You have also a DOI number which refers to all versions, which is the one you want to cite. And if you go to the DOI number, then it brings you immediately to the latest version of the dataset or workflow. We have been using tagging here, so you can find all the Mood datasets ideally. Maybe not all have been tagged so far, but hopefully yes, with the Mood H2020 tag. So it should be easy to navigate in the wealth of data there. And there's, of course, another geo network-based metadata catalog, which is under the Mood domain available. Here you can search by keywords, you can search by spatial extent and so forth. And those catalogs are also talking to each other. So we are running Mondialis, our own catalog, and there are other in the group. And so we are feeding into, if we do an update, they are feeding into the central Mood catalog as well. So some pretty pictures, different variables we have been producing. You see it's the Mood country. Let's say the extent what we defined initially, what is the Mood country, and air temperatures. This is mostly time series we have produced, the individual data sets, also then all kinds of aggregation. The Zenodo example you see also there's a screenshot ideally. And we have also been computing data like relative humidity. You usually don't get that easily at continental scale. And we have been using ERA5 data with some formula and then produced those data sets. Daylight photo period was just mentioned earlier today, also available there. Cumulative temperature mask, which is a more of an effort, which is then using thresholding, filtering, map algebra, and so forth to come up with cumulative temperature mask above a certain threshold and below another threshold. And like this, you can also see what the spatial extent is over time. GeoNetwork example in the lower line in the middle, the catalog, and then mobility data, also relevant for Mood. Yeah, what else are we doing? Value added. So converting data is one thing, aggregation is another thing, and there's a third one, which is improving the spatial resolution. This is, of course, not like geospatial alchemy, but it is based on geospatial models. So we are using different resolutions here, like the 12-kilometer pixel data from ERA 5 land as an example, then using kind of static Chelsea precipitation data, which are not time dependent, but from this you can grab the information how to fine-tune the spatial resolution, because it depends on the elevation and let's say the terrain and other effects. And like this, you can come up with a kind of fusion product, which is the ERA 5 data at 1 kilometer resolution. And also before we heard maybe higher resolution might help to discover effects, local effects, and this could be one way to go. During this improvement, or let's say enhancement, better to say improvement is maybe not the right term, we also derive all kinds of statistical measures like quartiles, min max, whatever you can imagine, so to assess also the quality of the data set. Data reduction is another example with time series, like for example the MODIS data starting in the year 2000, the time series, 4 maps per day globally. It accumulates to tens of thousands of maps. That's not easy to handle and not even worth it possibly to feed into a model. So what we do here is we use different approaches like Fourier transform in order to aggregate those data over time and see what is, for example, the seasonality in the data. And so we distill indicators out of this using Fourier transform. You get mean level here in this example to the left from NDVI, or the peak day, what is the peak day or the peak date, yeah, and all this kind of variables you can derive from this. So we are looking into different periodicities here in order to reduce the amount of data which then goes eventually into the modeling. Yeah, with this I want to come to my conclusion. Our offer, as you have seen, is a huge range of data. We have, I don't remember how many hundreds of data sets produced, available through the catalogs you can access. We could not put everything online because some data are reaching the terabyte range, so this requires kind of negotiation how to transfer those data to you. Of course, that's also a chance to improve modeling. So importantly, we need to talk, continue to talk. We can also often offer various approaches to a problem. Like Westnal, we have heard importance of temperature data as an indicator, and we have different choices here, and you can explore what fits best your model. I mentioned that we have open data here and also open source tools, so the workflows are reproducible here for sustainable epidemiological frameworks. And we are also involved in the Mood INPA, so Mood Foundation efforts in order to ensure that data and methods remain accessible in the future. Yeah, and not to forget, if you are developing an application like mobile application, naturally you do not want to host the data locally. Here's also the chance to use APIs in order to access where the user is, this asset of data in this particular area. So no need to transfer everything, but you can just go on the fly and do whatever you want in your application with the data which are accessible here. With this, I would like to thank you for your attention, and thanks to all the Mood partners giving contributions here to help us going into the right direction and producing ideally useful data for you. Thank you.